Okay, so we started off with this question. Piece of tin foil between a light source and a piece of paper. So then the question was basically what is going to show up on the piece of paper. And we had a couple guesses here. We thought that maybe we'd have a little circle, maybe the size of the pinhole, maybe a little bit bigger. We thought that maybe the circle might be a little fuzzy, might be a little bit dimmer. These characteristics might change based on whether the piece of paper was far away or close to that tiny little pinhole. So, is this what we saw? No. What did we see? Yeah, we saw the actual image, and it was flipped upside down. And it wasn't just flipped upside down. What else was it? It was teeny tiny compared with the actual object. What else did you notice, especially at the location over there? What's that? Yeah, it's mirrored. It's not just flipped upside down. It was also flipped left-right. I know, it's crazy. So it's like, you know, it's one thing to see this and just kind of be amazed at what's going on, because how in the heck can light going through a tiny hole show up as an actual image on a piece of paper? But it's a whole other thing to actually try and explain it all. And that's the goal of today. Any thoughts on how what we saw in our experiment actually works? How is it that light going through a tiny little pinhole can make an entire image much larger than the pinhole itself? Yes?
Maybe the light goes through the pinhole and then just keeps going to the paper. So all the light makes the image because the top of it goes through and the bottom also. So the bottom goes through and goes to the top.
Sure. Let me see if I can draw what I think you're saying here. So we'll say that this is the basketball player in the corner of the room that we saw. And this is the piece of tin foil, much bigger than the actual piece of tin foil. And then this is where the piece of paper is. So you're telling me that if a ray of light starts here and goes through that hole, it's going to end up down here? Is that where you were going with that? So if I have a light ray from the top of the basketball player's head going through that little pinhole, it's going to have to show up somewhere right there. And I think you were saying the same thing for the bottom, right? So on the bottom, in order for these light rays to make it through that pinhole, they have to go up at a certain angle in order to make it to that sheet of paper. So what does this mean? It means that he's exactly right. Well done. Right off the bat. Man, usually this takes a little while. So the light rays from the light source's top can only go through this pinhole and make it to the piece of paper taking one path, because the pinhole is so small. Therefore, if the light ray from the head end up here, that means the top of the head's going to be right there. And the feet are way down here. They can only take one path to get through that small pinhole. They have to go up at a very large angle, meaning the person's feet are going to be located right here. Man, not quite drawn to scale, but you get the idea. And that's exactly 100% what's going on in this case. You've got light rays being produced from the entire image, and based on what locations those light rays are coming from, in order to make it through that little pinhole, they can only take one specific path, because the pinhole's so small. And so the stuff from the bottom of the light source have to go up, the things and the light rays from the top of the light source have to go down, and you get yourself an inverted image on that piece of paper, on the screen where it's showing up. And that's why we see what we see. And you can think of this left and right as well. You know, if the light ray's coming from over here, and the pinhole's right there, light rays got to go like this, and will end up on the opposite side. So it works up-down, and it works left-right as well. Not really a whole lot else to say about this. Any questions? Yes?
Didn't you see it without the tinfoil?
Well, because if you don't have this hole here, then all of these light rays are going to show up on all of the piece of paper. The only way this works is if it's going through a very small pinhole. Because if you think about it, let's say we make the hole much larger. Now, another light ray from the head could end up down here. So now you've got the tip of that image's head over this huge area. And the same thing for the feet. The feet would be spread out over this area. And so you end up with just a giant fuzzball then. Other questions? Alrighty. You mean left, right? For the exact same reason that it was flipped upside down. Because if you've got yourself a pinhole right here, and imagine the screen's back over here, and maybe the object has a piece of light coming from this spot, in order to make it through that pinhole, that light ray has to go this exact direction, go through it, and it's going to end up on the opposite side. So that works for left, right, and it works for up, down with that inverted image. Other questions on this? Okay, because you guys nailed that right away, you've got a lot of time to do this homework. 15 minutes. And this is much shorter than the last one you got. So I would think that you should be able to get this finished and packed away well before the hour ends. Now again, like always, not everything that we talked about up here is explicitly on the homework. There's some parts in here where you're not going to know the exact answer from what we did, because I want to see what your opinion on a couple of these things are. Like it asks at one point, what happens if you have two pinholes? You know, we didn't talk about that, but I'd like to hear what you think about that. There's actually a question about what happens if you make the hole larger. So you guys anticipated that one pretty good yourselves too. All right, I'll get this passed out. This is going to be due tomorrow. Oh, and then I suppose I should say, so yeah, the answer to the question is you have an image that's flipped upside down and flipped left and right. End video.